Hello friends, welcome to the another video on PEE, and this question is asked in December 2009 paper, and I represent December 2009 in this manner. Okay, so the question say a circuit has a inductor reactance, okay, 20 ohms at 50 hertz frequency. Its resistance being 15 ohm for applied voltage of 200 volt 50 hertz. Find power factor, second, current. Okay, so the thing is, what is given is inductive reactance and what do you say, resistance, and the total voltage is given to me. So I need to find a current. So from Ohm's law we know that the formula of current, to find a current, is just I equals to V upon R. But in this case the resistance is not one, we have a two resistance, so we need to find the combined resistance of the circuit, which is also called as total resistance, or RT, or a load resistance, that is RL. So it is also called as RL, but remember, RL is the combined resistance of inductor and pure resistance. Okay, so by this formula I can easily find current I. The total voltage is given to me, that is 200 volt, but I don't have the value of RL. I not provided with the value of RL. I have to find this value before solving the problem. I have to find this value. Okay, and we will see how to find this value. And the second thing which is asked is power factor. As you know, the power factor is just simply cos phi is the power factor. Okay, is the power factor. But I don't have the value of phi. I am not provided with the value of phi. So the second thing to find the power factor is to find the value of phi. And as we know from the inductor circuit, that the value of phi can be calculated in the formula, or from the formula of tan inverse. And what is that formula, we will see further. Okay, so let's proceed to how to solve the problem exactly. Okay, this is only a brief introduction to the problem and the idea uh, on which we have to walk to find what is asked. Okay, so the first of all, I need to find a total impedance of the circuit. uh, to imagine a circuit in your head, I will make it better by drawing on this board. So the circuit is like this, that is, you are provided with a inductor and then a resistor, and this all thing is applied with some voltage, which is a total voltage, and we have inductor reactance and we have pure resistance. So I need to combine these two things to form one single resistance. Okay, that is ZT. That is ZT, that is total resistance of or a total impedance of this circuit. We know that inductance, what inductance do, from the phasor diagram we know that the inductance lags behind. Okay, lags behind the circuit, and the resistance is just go in same direction. So this is my inductance, that is XL, and this is my R. So the resultant, if I want, this is my inductor vector and this is my R vector, and if I want to find the resultant vector, that is this, I will, what I will do, I will just this is 90 degree. So the value of inductor is 20 degree, which is given to 20, and the value of R is 15. So if I want to find this value here, so I will go by Pythagoras and I will find the value of R, that is total resistance of this circuit is nothing but just simply square root of 15 square plus 20 square. So the 15 square plus 20 square is the value, total value of R. Okay, so the total value of R is, the total value of RL, that is RL is 25 ohm. So this is the total resistance of our circuit, this circuit. So this is the total resistance of this circuit, that is XL and R, and this is our total resistance, that is RL equals to 25. As soon as I get the value of RL, the first thing I will find, that is current, and you can see the current is just a total voltage upon total resistance. So it is easy to find current by substituting the value of voltage, that is 200 volt, upon total value of resistance, which I found, uh, that is 25. Okay, so you can apply the table of 25, sorry, to find the current, that is 5 5s are 25 and 5 4s are 20, 5 1s are 5, 5 8s are 40. So the total current is 8 ampere. So this is my total current, that is I. So I found the total current in the circuit, that is 8 ampere. Now the next thing I am going to find is, I find the current in the circuit. The next thing I have to find is power factor. So the next thing I have to find is power factor, and so we will see how to find the power factor. And this can be found in this way, that we know the formula for power factor. Power factor is given by cos of phi, but we don't have the value of phi. So the first thing we need to find the value of phi, and the value of phi can be found from the phasor diagram, if you remember. So uh, this is my phasor diagram, in which you can see that this angle is theta, this angle is phi, sorry, this angle is phi, and tan inverse of this phi is a reactive element opposite upon adjacent, is the tan of this angle is opposite upon adjacent, and opposite is my inductive reactant, that is 20, and adjacent is my resistance, that is 15. So I will just do the simple calculation to find the value of phi, that is phi equals to tan inverse of XL upon R, simple R. uh, so, so, so the tan is RL, sorry, RL, the uh, okay, so the phi is given as, now the tan inverse of, what is value of XL, the value of XL is 20, and what is value of RL, the R value is 15, not, sorry, not RL, we don't need RL, we just need a R, value, not RL value, to find phi. The phi is tan inverse of XL upon R, that is 20 upon 15, which you will get 53.13 degrees. So this is the value of phi which is required to find the cos phi, that is power factor. Now I will substitute this value in this equation and find the power factor. So my power factor is just going to be cos of sorry, cos of 53.13 degrees, and if you find, then you will get that the power factor is equals to cos of 53.13 is nothing but just 0.6. So this is my power factor. So just take a quick revision what we have done. We have this problem over here and we need to find a power factor and current. uh, I have given with XL and R. I first combined these two individual resistance to find the total impedance of the circuit by using this formula that total impedance is equals to uh, square root of XL square plus R square. Okay, then afterwards I just find that the total impedance is 25. Now it is easy to find a current as I have the uh, value of total impedance over here. By substituting the value of V and R, I find a current. After that, we need to find a power factor, and by formula of power factor, to find a power factor we know that power factor equals to cos of phi, and but we don't have the value of phi, so we calculated from our knowledge of a phasor diagram that the angle phi is just a tan inverse of XL upon R. So the tan inverse of XL is 20 and R is 15, so I find the angle that is phi, that is 53.13. Now just substituting this 53.5 in cos power factor formula, I find the power factor. So thank you.